Good afternoon students. In today's class we will discuss regarding calorific value, carbonization of coal, types of carbonization, composition of fuel gases and their uses, and fractionization of coal tar, and then coal liquefaction and coal distillation or coal gasification we will study in today's class. Now, calorific value. A calorific value may be defined as the amount of heat liberated in calories by the complete combustion of combustible material with oxygen and the condensation of the product to desired temperature. Whatever the amount of heat liberated in calories, that is called the calorific value. The amount of heat liberated in calories by the complete combustion of a combustible material. The amount of heat liberated is called the calorific value. Here one of the example we have taken. Consider the combustion of carbon and hydrogen, which may be represented as carbon plus oxygen gives rise to carbon dioxide. What is the atomic mass of carbon? 12 grams. Oxygen is 32 grams, gives 44 grams of carbon dioxide. And the amount of heat liberated will be 97,644 calories. Okay. Similarly, hydrogen and oxygen H2O, the amount of heat liberated will be 69,000 calories. So, what we have to observe here, 12 grams of carbon gives 97,644 calories of heat. If 1 gram of carbon would give, 1 gram of carbon undergoes a combustion would give 97,644 divided by 12. What will be the amount? That is 8137 calories of heat. Similarly, the 2 gram of hydrogen gives 69,000 calories of heat. 1 gram of hydrogen gives how much? That is 69,000 divided by 2. That is equal to 34,500 calories. So, on the basis of this, the mean calorific value of any fuel containing a carbon and hydrogen. The mean calorific value of any fuel containing a carbon and hydrogen can be calculated as total calories is equal to percent carbon into 8137 plus percent hydrogen into 34500 divided by 100. Okay, so what is the formula we are using? Total calories is equal to percent carbon into 8137 plus percent hydrogen into 34500 divided by 100. So, what is the calorific value? Calorific value is nothing but it is the amount of heat liberated in calories by the complete combustion of a combustible material with oxygen. Now the carbonization of coal. What is the carbonization of coal? The process of converting a coal into coke and coal gas. The process of converting coal into coke and coal gas in absence of air at high temperature is carbonization of coal. Carbonization of coal is nothing but it is a process of converting a coal into coke or a coal gas at a high temperature. It is called the carbonization of coal. So the process of carbonization, how it takes place means at 250 degrees Celsius, the moisture and gases lower olefins will evolve, and at 350 degrees Celsius, evolution of tarly vapors, and at 400 degrees Celsius, the coal becomes soft and plastic-like, and at 700 degrees Celsius, hydrogen gas will evolve. At 800 degrees Celsius, gaseous products evolve, which on further heating converted into coke. So this is the process of carbonization of coal. What is the carbonization of coal? Carbonization of coal is nothing but it is a converting a coal into coke and coal gas in absence of air at a high temperature. Next is types of carbonization. There are three types of carbonization of coke. First one is lower temperature carbonization, LTC. Second one is medium temperature carbonization, MTC. And third one is higher temperature carbonization, that is HTC. Now, lower temperature carbonization, that is LTC, is carried out in the temperature range of 500 to 700 degrees Celsius. And in this type of carbonization, the yields of liquid products are higher, while that of the gaseous products is low. And the coke produced has higher volatile matter and is free burning. So LTC is carried out at a temperature of 500 to 700 degrees Celsius, and the yield of liquid products are higher while that of the gaseous product is low. And whatever the coke produced, what is the carbonization? The converting a coal into coke. So LTC is one of the method of carbonization. So here also the coal is converted into coke. So the coke produced has higher volatile matter and is free burning. And next is medium temperature carbonization. In medium temperature carbonization, the temperature range is around 800 degrees Celsius, and this carbonization produces smokeless soft coke. Byproducts produced are similar in characteristics to high temperature carbonization. Whatever the byproducts produced in this step are similar to high temperature carbonization, and it is rarely practiced in these days. And next is high temperature carbonization, and this high temperature carbonization is carried out at a temperature range which is above 900 degrees Celsius, and this carbonization gives higher yield of gaseous products and lower yield of liquid products. But in case of LTC, the liquid products are more as compared to the gaseous products, but in case of high temperature carbonization, the gaseous products have higher yield as compared to the lower yield of liquid products. Here in this diagram, you can observe the coal carbonization process also. How the coal carbonization takes place, you can observe. Next is composition of fuel gases. In that, coal gas, the composition of coal gas. Coal gas consists of hydrogen 40%, methane 32%, carbon monoxide 7%, ethene 3%, ethane 2%, nitrogen 4%, and carbon dioxide 1%, and rest is 4%. So this is the composition of the coal gas. Next is the composition of a producer gas. And the producer gas consists of carbon monoxide 22 to 30%, and that of hydrogen is 8 to 12%, and that of nitrogen is 52 to 55%, and that of carbon dioxide is 3%. This is the composition of a producer gas. Next is the composition of water gas. Water gas is also called syngas or synthesis gas. What it consists of: hydrogen is 51%, carbon monoxide 41%, nitrogen 4%, and carbon dioxide is 4%. And this is the composition of syngas or synthesis gas. It is also called a water gas. Here in this you can observe applications of coal gas, where the coal gas is used. You can observe. And next is uses of fuel gases. In that, uses of producer gas. The producer gas is used for heating the open hearth furnaces in the manufacture of steel and glass. and it is also used for heating the muffle furnaces and retards in the manufacture of coke and coal gas, and it is used as a reducing agent in certain metallurgical operations also. These are the uses of the producer gas. Next are the uses of water gas. Water gas is a good heating fuel because of high calorific value. As already we know that what is the calorific value. So water gas is a good heating fuel because of high calorific value, and it is a good source of hydrogen on commercial scale also, and it is used in the manufacture of methyl alcohol. So these are the uses of water gas. Next is fractional distillation of coal tar. Here the chart they have given the fractional distillation of coal tar chart. You can observe here the light oil, heavy oil, middle oil and anthracene. What it light oil consists of benzene, toluene and xylene, and the heavy oil consists of cresol, naphthalene and naphthol, and the middle oil consists of phenol, cresol, naphthalene, and anthracene oil consists of anthracene. In this, you can observe the temperature range and name of the fraction, whether it is a light oil or heavy oil or a middle oil, and what is the temperature range and what constituents it consists, and what is the percent, that how much percent it consists. That chart they have given here. The temperature range is up to 170 degrees Celsius, and in Kelvin up to 443. So the name of the fraction is light oil, and the constituents present are benzene, toluene and xylene, and how much percent is 2.25%. And similarly 170 to 230 degrees Celsius, 443 to 503 Kelvin, the name of the fraction is middle oil, and the constituents are phenol, cresol and naphthalene. Percent is 7.5. And similarly for the heavy oil, that is creosote, you may call it as creosote, 230 to 270 degrees Celsius temperature range, and the constituents present are cresol, naphthalene and naphthol, and the percent is 16.5%. And the temperature range 270 to 360 is anthracene. Anthracene, it is also called green oil, and the constituents present is anthracene, and the percent is 12%. And at last, pitch residue is still present, that is the constituent present in pitch residue is carbon, that percent is 56. In before also you have seen that the carbon still remains as a residue with 56% content, so that is a pitch residue, we may call it as pitch residue. In that, what is the constituent present in that residue is, that is carbon, and the percent is 56%. This is the fractional distillation of coal tar. Next is coal liquefaction. The coal liquefaction is a process of converting a coal into liquid hydrocarbon. We are converting a coal into liquid hydrocarbons. That process is called the coal liquefaction. Liquid fuels and petrochemicals. We are converting coal into liquid hydrocarbons, that is a liquid fuels and petrochemicals, and this process is often known as coal to X. Coal to X or carbon to X. What is that X indicates means X can be many different hydrocarbon based products. X is a many different hydrocarbon based products. However, the most common process chain is coal to liquid fuels. Coal to liquid fuels. Generally, the coal liquefaction takes place coal to liquid fuels. The process of converting a coal into liquid hydrocarbons. That liquid hydrocarbons will be a liquid fuels and petrochemicals, and this process is often known as coal to X or carbon to X, where X can be many different hydrocarbon based products. However, the most common process chain is coal to liquid fuels. This is called the coal liquefaction. Next is coal gasification. What is the coal gasification means? Process of converting coal to syngas. The process of converting a coal to syngas. What is the syngas? It is a mixture of carbon monoxide, hydrogen, carbon dioxide, methane, water vapor. Already you studied. So the coal gasification means it is a process of converting coal to syngas. Or you may also call gasification of coal is a process in which coal is partially oxidated by air, oxygen, steam or carbon dioxide under controlled condition to produce the fuel gas. The syngas is a fuel gas only. So you may directly call the conversion of coal into syngas is called coal gasification. So this is about the gasification of coal.